and Q is undefined. What did I do wrong here? Oh, right. That's B. Okay, let's assume that that number is correct. Okay, so some subtleties. Yes, so X and Y are private. So this is why I wanted you to do it yourself, so that you may run into these questions. So X and Y are private, and so why are we allowed to write this? Well, it's not private to yourself, but it's private to anyone of that class. It's a design decision that you may quarrel with. But basically, yes, even if it's private, another object of the same class, private, but object of the same class, come on, class can access. Now, you could also do the following. Did anyone do this? Did anyone do this? Write a function get my y, which just returns the y value, and then do y minus the function get my y from the other. So that is a solution too, but I don't like this. And potentially dangerous. Well, no. Let's just keep it like this. Okay, so there is a temptation to write this sort of functions. Okay, y, so let's call it my y. There is a temptation to write that sort of functions and then use that in your main program. But remember that what counts for objects is the functionality. And getting the x or the y coordinate is not a functionality. That is tinkering with data. And so you should really think, if I have a point class, what is the functionality I want? Okay, I want distance to another point, I want angles and that sort of thing. But I do not intrinsically want the x or the y coordinate. You use that to do something else, and in that case you should write the else directly. And there are more problems with this. We'll get to that. Okay. Yeah, okay, so you can do this one when you get home. Now, if you have 2 points, point P and Q, write a function h that gives you the point halfway P and Q. If you did the previous exercise, then this should not be terribly hard to do. Okay, here's a subtlety. So suppose you want to write point P1 is something, and then I make a variable P2, and I later in the program say P2 becomes P1 scaled by something. Now this looks perfectly plausible, but depending on your compiler, you get various error messages. Let's see, point C C is B scaled to, and get rid of this. So let's see what the compiler says about this. The Intel compiler, okay, it's quite explicit. So this line, point C, it complains about. The GNU compiler, at least the last time I tried it, said no matching function for call point point, which is kind of confusing. What does that double colon notation mean? And the Intel compiler says no default constructor for class point, which is as confusing until I explain to you what a default constructor is. Did anyone try this with Clang? What does the Clang compiler say? So if you have a working code, just put point C and feel free to post it in Slack, in chat. Okay, so what's going on here? Well, the problem is that P1 is created with the constructor that you gave. P2 does not have the coordinates, and so it tries to use what is known as the default constructor. The default constructor is the thing that has no arguments and does nothing. And if you do not write your own constructor, then the default constructor exists. So if you hadn't written your constructor, then you could use the default constructor. But as soon as you define any constructor, the default constructor goes away. So if you have a constructor and you want to write this, then you need to redefine the default constructor. Okay, so I guess maybe the lesson is that you should not write a declaration without initializing the point. So for classes, it's not a good idea to say, okay, here is a variable and it's going to become, it's going to be filled in later by copying from something. Because this is not a variable declaration. This actually creates a point object. So if your point object has a lot of interior crap like arrays, they do get created here. Okay, so yeah, you can draw two lessons from this. That if you want to write this line, then you need a default constructor, but maybe you should not want to write this line. Anyway, default constructor. The GNU compiler says no default constructor exists, and so now you know what that means. And the GNU compiler, at least in this particular version, said no matching function point point. And so this double colon notation, we'll get to that in a minute, means class point, member function point with no arguments. So it says there is no point of empty arguments in the class point. Okay, default constructor. Yeah, not going to go into this, but so just to emphasize that classes are not about storing data, but they are about functionality. You can make classes for fairly abstract things. So let's make a class that gives you a stream of integers. Internally, you so you make a stream integers, and you keep calling next and next, and it prints out 0, 1, 2. Come on, I wanted to select this. Anyway. So how do you design a class that every time you say next gives you the next thing? Python programmers, how do you do that in Python? I love Python generators. I use them left and right. Anyway, so in C++, you explicitly write this next function, and internally you maintain a variable, what is the last thing that you've coughed up, and then return last result plus plus. So return and then increment. Okay, so this is just to emphasize that classes can be pretty abstract things. And this is sort of an infinite data structure, because as long as you don't ask for the last element, you can produce the next one. And yeah, so this is a preliminary to the following exercise. A prime number generator. So a prime number generator basically has an API of a function. What is the next prime? So you want to be able to write a program. Oh, I didn't mention cin yet. Let me briefly do that. If I have an int I only showed you the output. Here's how you do input. So cin. So output, the left arrows mean stuff goes into the output. Input means stuff comes out of the input. Okay, cin, just to illustrate. Oh boy. Hello world 5. That was 5. Okay, so that is cin. Should have mentioned that earlier. Okay. Yeah. Let's save this one. You can do it during the lunch break or something, but it's kind of a cool exercise. Okay, when I was writing that function my y, I said that there is a variety of reasons why I don't like it. See, instead of just returning the value of an internal, so again, private double xy, you can return x as a value, but you can use the reference syntax and you can use a reference to the x component. And so now you have a point and you can say, okay, set my x component to 3. Okay, this stuff is an invitation to accidents. This is very dangerous code. You should not willy-nilly tinker with internals of a point. Think in terms of functionality. What do you want to do with a point? You want to translate it or rotate it or scale it. But you almost never need to tinker with the internal components internally. And so let's say we make a class point on the unit circle, and so we store an x and a y, and we have a function. What am I doing here? So you create it from x, and you set, and then there's a function y. So the y is the square root of 1 minus x squared. Okay, so a point on the unit circle, I guess only in the upper half circle. You give it an x and it computes the y. Now in this class, it would be dangerous if you were able to tinker with the x and the y. There is an x and a y stored, and you may want to ask, okay, what is my x? But you do not want to be able to set the x, because then the point is no longer on the unit circle. Okay, so think of a class as supporting functionality and but also think of it as objects that satisfy a certain predicate. And your methods are written in such a way that the predicate stays enforced. So in this case, tinkering with just the x on the y of a point on the unit circle violates the predicate. Okay, so arbitrary data access is not a good idea. Don't write functions like that. Now, one place you could do it is if you're, okay, you don't know yet what a vector is. A vector is an array. So suppose you write a finite element class grid, and you have the points, and for whatever reason you really want to expose the points, but you don't want to have them alterable. Then you can use this const reference construct again. Okay, we're getting into obscure stuff. If you got this, fine. Otherwise, read it again in a couple months. Basically, don't tinker with the internals, or use const to protect yourself from yourself. Okay. Yeah, one of the people here who speaks Python mentioned self. So, inside a class method, you can actually get hold of yourself through this. This is a pointer to yourself. So this is rarely ever necessary, because in this line should have been done with an initializer. But there are cases where you have a function that operates on a class, and now inside the class you have a method that wants to call this function, and so you need to say, okay, I get hold of myself and I pass it to that function. Okay, again, we're getting into obscure stuff. If you're just learning about object-oriented programming, ignore this. But for future reference, remember that it is possible to get hold of yourself through the this keyword. It's like self in Python. Const functions, more constructors. Oh, yes. So, so I have a class which contains an int. So you create the class from the int, and my constructor prints out a message. Okay, now here is a weird one. So it says has int here as function name, so it is a constructor. But it is a constructor from a has int. Okay, so this syntax where you have a constructor that takes an object of the same name as argument is called a copy constructor. If you have an object, then it is simple to make a complete copy of it by using the copy constructor. Let's see. So here's code. Has int. I make an object unint, which contains 5. And so the constructor says, I set myself to 5. then in this line, the other int becomes a copy of the first int, and on the previous slide, the copy constructor says, okay, I copy myself from 5, and now if you print them, they both have 5. Okay, so there's the constructor, there is a copy constructor. It is extremely convenient programming that it's possible to make a complete copy of an object. Suppose you're programming the traveling salesman problem and you have the search strategy up to this point, and now there are 2 choices. Then you just make a copy of the object, and the one goes the one way, the other one goes the other way. Extremely efficient programming. Finally, there is the constructor, the copy constructor, there is a destructor. So normally, which is the class name preceded with a tilde. The default destructor does nothing, but the destructor deallocates all the data of an object. Now, if your object involves, for instance, opening a file, then the file does not automatically get closed. And so you would write your own destructor which closes the file that is associated with the object. An example of how this works. Ta-dum, pum, 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 pum. Headers. Yeah. I think I want to take a 5-minute break just for everyone to cool down, and then I want to talk about classes and other classes, and in particular inheritance. This is a tricky subject, so you can read this at home or so. 5-minute break. Okay, I'm sharing screen. My sound should be on, and the recording is still rolling. Let's see, where did the chat go to? Okay, yeah, so multiple classes and how they can relate to each other. So the terminology that is used is has-a and is-a. Has-a is a little vague. Come on. Ah, sorry. My keyboard was looking at my other computer. A class usually contains data members. These can be simple types, or they can be other classes. And so this allows you to make nicely structured code. So suppose you made a class person, and then a course is, of course, the instructor, the year, the syllabus, and later an array of students. But the has-a relation is a course, has-a, instructor. Now, this has-a can be literal or it can be more metaphorical. So let's say you have your point class, and you make a segment class, and then there is a method get the endpoint, which returns the endpoint, and you use that in your code. Segment, some point is get the endpoint. But so right, so I'm storing the starting and the ending point here explicitly, and so getting the ending point is easy. It's return a copy of the endpoint. Note that this is indeed a copy. But what if you store your segment as a starting point and the length and the angle to the endpoint? In that case, your segment class does not really has a point endpoint, but it acts like it has, which reinforces my point about functionality. So getting the endpoint is not data retrieval, it is functionality. And sometimes that functionality comes from data retrieval. Sometimes, in this case, you have the starting point and then the length and angle. Getting the endpoint is some computation. Okay, so from the API, you cannot decide if the implementation is actually that it contains something. One reason for doing things this way is that maybe you want to be able to construct your class two different ways. So here we have a segment and we store it as 2 points, or we have a segment and we store it as point length angle. But now what if you decide to go with this design, but in your code it's more natural to say, okay, here's the start point and then this is the length and angle. Now you cannot, now what constructor do you use? Or suppose you use this design, but you want to construct it from 2 points. Okay. I mentioned polymorphism. You can have two functions with the same name as long as they look different enough to the compiler. So here is what you here's what you do. You use this polymorphism concept in the constructor, and so you say, okay, I am not going to say immediately how I implement, how I do the data realization, but I make one constructor of a point length and angle, and I make one constructor out of a point and a point. Okay, so now it is irrelevant what you actually has. It can appear either way. So this polymorphism is a pretty neat mechanism. It means that the outward appearance of your class, the API, can look two completely different ways, and the internals stay the same. Yes, so you have your file with the point class. Skip point number 2, do exercise 1. So make a class rectangle with a constructor from 2 points, and then write at least the function area. So I'm going to be coding this, but please code along with me, because the next exercise I really want you to do for yourself. Oh yeah, and so okay, the rectangle is constructed from a bottom left point. So it's a rectangle that is parallel to the axes, and I constructed from the bottom left point the width and the height. Does anyone have a suspicion what the compiler is going to say about this? Anyone want to predict? Did anyone already make this mistake? Stephen, yes, of course. Compilers pretend to be one-pass compilers, and so it goes top to bottom down the file, and so it complains that point is unknown. So let's pick up the whole caboodle and just put it at the end of the file. Oh, let's see. Rectangle patch is point A 3 and 2. All right, and my question was implement the area method. So double area. What do I return? Width times height, yes. I hope other people are following along too. Stephen, your name looks familiar to me. I'm sure I've handled tickets from you. Oh, right, that's rectangle, yeah. Okay, does that look decent? All right, and width times height. That should be 6. Area is 6. Okay, so this is a case of a has a pattern. A rectangle has a bottom left corner. You already knew that half an hour ago. Now we're going to be doing the fun stuff. The is-a relation. Okay, this is dangerous. Java. This is called inheritance. And inheritance is a great thing, but you have to be careful. So with inheritance, we have base classes and derived classes. So for instance, a base base class, if you're writing a payroll system, is an employee. An employee has a salary and an employee number, but then there is a derived special case. The manager is of course an employee, so they have a salary and an employee number, but the manager also has underlings. Another base case is, suppose you have a drawing program and you have a general shape. So the shape has a bounding box and it has a drawing routine. And I don't know, the drawing routine does some complicated interpolation through the points of the shape. But then there is a special case of a square where the drawing routine is much simpler. So there is a base case and there is a special case. And there are various relations between the base case and the base class and the derived class in how they can relate with their methods, and we'll cover that. But I want you to see one case for yourself. Okay, what does this look like? So let's say that we have a general case and a special case, and so the general case has a general method, and it has some data. And now note that it's neither public nor private. It's called protected. Protected means it is not public to the world, but it's private to the class itself and to any derived class. Okay, so now I make a special case. So that's the derived class. The derived class, public general, so it derives from general, and yeah, it says public here. You could have private there, but that doesn't happen a lot. So just put it in your motor memory. Whenever you do inheritance, just type public base class name. So this says that the special case comes from the general case. And so that means that anything that's in the general method is accessible in the special case. For instance, this internally implementation variable G, you can now access. Oops. So the special case has a method that is not in the base case, but it needs to use the general variable G, and it can access it. Right, so the general method, the general class had a general method, and now if you make a special object, it has the special method because it is special, but because it came from the general case, it also has the general method. Okay, this exercise is a little abstract. I want you to do exercise 9. Okay, so corresponding to the, we need to get a couple small things out of the way. Corresponding to the syntax where you say that the special case comes from the general case, if your general case has a constructor, so let's say your general case is something of two inputs, and the special case comes from the inputs are related to each other. So you say class special inherits from general. Oh, I didn't mention that word yet. If base class, derived class, then the derived class inherits, and so it can use everything from the class that it inherits from. So special inherits from general, and that means that the constructor also needs to invoke the other constructor. So the special case constructor, the derived constructor, needs to invoke the base constructor. And you do that with the colon notation. The colon notation is ambiguous. It means initializer list, or it means call the constructor of the base class. And so suppose my general case is of two independent variables, and the special case is the special case where the two variables are dependent. So then you would say, for instance, the special constructor corresponds to the general constructor, but the two variables dependent as one is one more than the other. Okay, so you have in the class declaration, you indicate what the relation is, and then usually you also have to invoke the base constructor in the derived class constructor. So private means strictly internal to a class. Public means anyone can get added. Protected means private, except that derived classes can use the data members. Okay, now here's your exercise. So we had a rectangle which is constructed from a bottom left point, a width and a height. Now I want to have a class square, which is a special case of a rectangle. What's the difference between a square and a rectangle? Oops, yep. So I'm changing this to protected. Okay, so now I want to make a square. How much do I spell it out? A rectangle comes from a point, width, and a height. So a square is defined from what? So question from me to you, what should the constructor of a square look like? And now bearing in mind that the constructor of the derived class needs to invoke the constructor of the other class, I want you to get this code working. Okay, so that's the exercise. I will give you 10 minutes for that. Let's see, are there optional other exercises? No. Okay, chew on it. I'll be back in about 10 minutes. So you need to fill in the details of the square class and write the main program so that you can test it. Okay, so first of all, the main program. So if a rectangle is a bottom left width and a height, the square is a bottom left and only a width or a height, right? Because it's the definition of a square that it's the same. What was it? Double? So does square need to store anything? Let's not think about that. Okay, so if you know how to make a square from a point, a width and a height, sorry, a rectangle from a point, width and a height, how do you make the square from a point and combined width and height? So the constructor of the derived class probably needs to invoke the constructor of the other. What's the missing bit? Did anyone figure this one out? Yep, Tiago, that is correct. A square with a bottom left and a width height is a rectangle with the bottom left and identically the width and the height. And that's it. Do we need to do anything else? Do we need to store any private or whatever data? Any more code in the constructor? No need. I agree with you. Oh, what did I miss? Oh. What did I say? Right, the width and the height is 5 and the area is 25. Okay, so what you've seen here is that the square used the constructor for the rectangle. It just indicated what was special about it. And then because the rectangle class had an area method, the square class now also has an area method. And so that's why I was, let's see if I can get the whole thing on one screen. Yep, almost. So the rectangle method has an area, and that's why when I make a square, I can also ask its area. So code reuse, and this is pretty powerful. So the square the derived class can be different in a whole number of ways, but you're reusing the code from the base class. So if the code is general enough to cover that, you can reuse it. So yeah, so one of the examples you see in many tutorials is a drawing program. So you have a general shape routine, and then you have special cases for squares, circles, whatever. Okay, clear? So in this case, we had the area method being inherited. So the base class defined the area method, and the derived class inherited it, unaltered. But sometimes you want to change it. Okay, so there are 3 different cases. One, the derived class inherits from the base class. So the routine has been written general enough that it can be used. A derived class can define a method that the base class does not have. Oh boy. Is there a property that a square has that a rectangle doesn't have? Nah, can't think of it, but sometimes your special case has methods that are not in the base class. For instance, the case of a payroll system, the manager has underlings, and so the manager has a method, how many underlings do I have? Or what is the average salary of my underlings? Okay, so inherit, create a new method, or override a base class method. So the base class has a method, and then you mark it as virtual. And then the derived class, you say virtual override. So that means get rid of the base method and use this one instead. Here's some code that does something. Okay, this is not about, so I guess we're now going into obscure topics in object-oriented programming, not directly about inheritance. this is really cool. So objects can be made to look very elegant. You can redefine things like the plus and the times operator. So we did the scale or scaled by method earlier. What if you want to write, okay, I have a point P1, and now I want to say my scale point is my original point times 2. That is much more elegant than saying dot scaled by 2, right? So how can you do this? Okay, so in your point class, you say, okay, a new point is operator times, ta-dum, ta-dum. So you're now redefining the star, and because star is such a special character, you have to say operator star. But other than that, 20 slides back, this said scaled by, but now it says operator star. So instead of doing point scaled by 2, you can now do point times 2. And so you just return that new point. Okay, operator overloading. You can do really fancy stuff. You can overload the equals. You can overload the square bracket indexing operator. So you can make an object that doesn't that internally doesn't remotely look like an array, but you can still redefine the square bracket operator. You can even define the parentheses, so the function call. So you can have an object, and then you can pretend that it's a function that you call on something by overloading the parentheses. Okay, this is really cool. You may find a use for it. Okay, so private, public, and protected. So data is either completely visible, completely invisible, or visible to people that look like you. But sometimes you really want two classes that are not hierarchically related to be able to access each other's method. And in that case, you can declare one class to be friend of the other. And then, so now private data is visible to your friends. Okay, so I mentioned the virtual mechanism where a derived class can have a different version of a routine in a base class. But sometimes there is no base case. So for instance, in the case of drawing shapes, there is no really general method. If you have a square, then it's a couple of straight lines. If you have a circle, it's circle. And if it's a general shape, then you get something interpolated. But none of these is a base case. So if there is no really base case, but you do want to say there has to be a drawing routine, then you get this. You say virtual whatever f equals 0. So you say this base case, there is no base function f, but and so you cannot create objects of this base class. You could, but oh, I missed the 85. It should really say derive public base. So this is a case where you cannot make base objects, you can only make derived objects, and so your base case is a shape, and the shape only says there has to be a drawing function, but there is no base case drawing function. And then every derived class, square, circle, spline thingamy has a derived function draw that works for that specific case. Okay, so this is called abstract, and this sort of class, I think if there is absolutely nothing in it, it's called a pure virtual, so you come across that name too. Okay. There is multiple inheritance. So you have a class that derives from A, but also from B. This can be dangerous. The dreaded diamond of death, or dreaded diamond of despair, sounds like something out of The Princess Bride or something. Yeah, multiple inheritance exists in C++ and Python, not in Java, if I remember correctly. Okay, that's it. We are at 1:15 Let's take a lunch break of exactly 1 hour, and then I will go into what? Vectors. Strings will be a short chapter. I.O. I will almost say nothing about. Smart pointers, that's a cool topic. And then I will very briefly go over namespaces, templates, exceptions, lambdas, those are cool, anonymous functions. I'll just mention, casts, yeah, they are very different from C casts, so I'll mention that. Tuples, so I'll just go briefly over a number of topics. Okay, lunch break till 12:45 Central, or whatever it is in your local time. And we're rolling. I think Jason was muted himself. Okay, so the next topic is all right, let's open the chat. Recording started. Yes, thank you. Okay, so the next topic is vectors. So if you're used to C programming, then arrays are just a big headache. If you ever try to write a function where the array is allocated in the function, but then you have to export it out, all this double and triple star stuff is just a big headache. C++ is much nicer in that respect. Okay, so vectors are fancy arrays. They are easier and safer to use. For instance, with a C array, there's basically no way to say, okay, this C arrays are almost the same as addresses. And so if you're looking at an array, you're really looking at an address, and there is no way to ask, okay, how big is this array? Addressing an array outside of the bounds, absolutely no problem. Memory leaks, I think I'm going to, in case you don't know what that is, I will explain about it. And if you do know, then you know that for complicated C codes, memory leaks can be a big problem. And finally, C arrays are completely static in the sense that you can never make them bigger. So in C++, basically, if you write malloc, you're doing something really wrong. And so C++ has something called new, which is almost the same as malloc, except that you don't have to do the size of whatever, so you it knows what type you're allocating. But new is almost never necessary. So did Christos join us? Nope. I got a question this morning. Yeah, so there are a couple of boundary cases where you would use new, but basically you never have to, almost never have to do explicit memory allocation yourself. Okay, so here we have a new syntax, vector of int. So just like you can have an array of this, an array of that, you can have a vector of int, and so the type carries the basic subtype around with it, and you use these angle brackets. You'll learn in about an hour what they actually mean. So it's easy to create short arrays by explicitly giving the elements. So vector of int numbers is 5, 6, 7, 8, 9, 10. And you can then access elements with the add function, which says take element number 3, which is actually the 4th element because C and C++ are zero-based indexing. There's a whole bunch of different syntaxes. So you can also put a equal sign here. So this is strictly initialization. This is, I forget what the technical name is. It does the same thing. So this thing between curly brackets is called an initializer list, and it's one of the more confusing things of modern C++. If you search online, you can find a lecture titled "The Horror That Is C++ Initialization" or something like that. It is kind of a messy topic, but for now, you can create a short vector of numbers, meaning a short array of numbers, with this curly bracket syntax. Okay. So if it's an array, how do you loop over an array? Well, you do for I is 0 to the length minus 1. Nope, you don't do that. Okay, so if you find yourself, okay, most of the times you are not interested in the index in the array. You are only interested in the value of the element. So it is completely artificial to say, okay, I loop over the index, and then the only thing that I do with the index is retrieve the element. So why can't I immediately get the element? Well, you can. So C++, I think this is 14 or 17, has this syntax. It's called a range-based for loop, and it's good to get used to this because this whole thing is extended yet further in C++ 20. So instead of saying for I is etc. and then element equals array sub I, you immediately say for every E which is a float in the array. So, and now E is the actual element. It's not the index, it's the actual element. So look at this code example, and for the moment pretend that auto says int. So you say for every int v in my numbers array, if v is more than the max, then the max becomes v, and after the array you print out what the max is. Okay, finding the maximum in an array has nothing to do with the index. You don't care about the index. Indexes are artificial. So you say, okay, for every value in this array, do something with that value. So that's where range-based for loops come in. If you really only are interested in the elements of the array, not the index, you do it this way. Now, if your array consists of floats, it's kind of redundant to say for float E in array. The compiler can figure that out. Okay, so this is the first time you run into the word auto, which means the obvious type. array is an array of floats, so E becomes float. Okay, so this is also modern C. Use type deduction wherever possible, and you'll see cases where it's actually necessary. So in this case, in this code, we have a vector of int, and so we just say for every auto v in numbers, which means v is an int, and so you look at that element. Okay, new syntax for element colon in array, range-based for loop. Now, suppose you want to go through the array and you want to multiply every element by something. In that case, you have to realize that this E is actually a copy of the array element. So if you would try to multiply E, nothing would happen to the array because you're multiplying a local copy. So if you do want to do something with the array, then you need to write for auto reference E. And so now E becomes in succession a reference to elements in the array. Short code example, a vector of floats that contains 1, 1, 2, 2, 3, 3. And by reference, you go through it and you multiply every element by 2, and then you print out element 2, which is the third, and it prints 6.6. Okay, so range-based for loops makes a copy of every array element. If that's an integer, you completely don't care. Usually the compiler will even optimize the copy away. So don't bother with the with small objects. But if your array contains larger objects, then you don't want to copy them. You want to pass them by reference. And then to prevent altering the data, you would do const auto reference. Okay, so I'm teaching you 3 different idioms within 20 characters. Const auto reference. So reference means it's not copied, you get a reference. Const means yes, you save on the copying, but you're protected against accidental altering. And auto means the type is whatever the compiler can figure out for itself. Okay, how do we create a vector? So I've only shown you creating a vector explicit from elements, but if a vector is 1,000,000 elements long, then that may be inconvenient. Okay, first of all, you need to include the vector header in your file, so include vector, and then using standard vector the way we had using standard cout, etc., etc. And after you do this, you can use the vector. Okay, now there are 3 different ways of doing it. You create an empty vector. So it only creates the block that contains the information about how large it is, which is 0 in this case. You create a vector with a certain size, and oh boy, I'd have to look that up. I think it's automatically initialized to 0, but I wouldn't count on it. And then there is the third way, where you create a vector with a certain size, and the whole vector is set uniformly to an initialize value. So 3 different syntaxes. Let's see, what do we have here? Yes. So I've shown you 2 different ways of getting the actual element out of the vector. One is with the add function. Come on. With the add function to get a specific element, or with the range-based notation where you take all elements in sequence. The old C notation with square brackets also works. So create a vector of integers, set it to 1, 4, add 3 to it, so that's 4, 4, set the second one to 8, print it out, 4, 8. So it's square bracket notation. Now there is also the notation that I already showed with the add function. So is there any difference between the two? Should you save yourself a couple of characters and use the square brackets? No, there is a difference. The square bracket notation is pretty much C-style pointer arithmetic. So calculate where the address is and then retrieve the value. But it doesn't do bound checking. On the other hand, the add function does use bound checking. So, but of course, bound checking takes time, and so this is slower. How much slower is it? Yeah, don't worry about it too much. So I would say if you have an array that consists of anything larger than just a single floating point number, I mean, the elements are more complicated, use the either use the add function or use the range-based notation. It is dangerous to use the square bracket notation because it has no bound checking. And if you are a C programmer, I'm sure at some point in your life you've wasted a day because you were off by 1 and you got element -1 or you got element subsize. I'm sure you've made that mistake at some point in your life, and with the add notation it would have been caught. So I would say try not to use the square bracket notation. This will only give you illusory performance gains. I thought I mentioned Knuth somewhere. Okay, so vectors, the new and improved arrays. So C arrays are kind of silly because they're basically pointers or addresses. And C++ vectors can be just as efficient and they're much easier to use. Okay, so the keyword new and malloc should not be used. Should we do this exercise? Maybe I'll save it up. So a couple things. Vectors can be easily copied. What happened in C if you had 2 arrays and you tried to copy them with a single statement like that? What would happen in C if they were traditional arrays? You would copy, in that case, you run into the copy the address. Yes, thank you, that's correct. C really doesn't have arrays, it just has pointers into memory, and so you would copy the address and then the 2 variables would both point to the same location in memory, so there was no copying of the actual data happening. C++ does the clean thing. A vector is a thing, so if you copy it, it copies the whole vector. But it copies it. It doesn't put 2 pointers to the same location. Here is a block, there is a block. You copy that block onto that, and now you have 2 blocks. Okay, a vector is actually an object in a class. So don't let the angle bracket notation confuse you. A vector is really an object. We'll learn about the angle notation later. It's an object, and you've already seen one method. So getting elements out of an array is use the add method of the vector class. So there is also a method size, so you never have to remember the size of your arrays anymore. They know what size they are. And then there is a ton more sections. So front is the first element, back is the last element, empty is a predicate, whether there are 0 elements in it. And there is a whole bunch more. Okay, so it's an object with methods. Okay, unlike C arrays, vectors are dynamic. Okay, now we have to tread carefully. When do you use this? Not too much, I hope. But so the function push back is, here's a vector, here's an element, and now I push it onto the back. So I have a vector of ints called myData. It's length 5, it's initialized to 2. So length 5. I push 35 onto the array, and now I print the size, and all of a sudden it is 6. And I print the last element, so myData sub size -1, and I get 35. Okay, so you can extend a vector. Likewise, there's pop back, which removes the last element, insert, which splices elements in the middle, erase, which deletes elements from the middle. All of this flexibility is great for certain types of codes, but in numerical codes, try not to use it because it comes with a price, of course. If you have an array, it's allocated somewhere in memory, and now you insert or you push back, then the only thing the operating system can do is allocate a larger array, copy it over, add the new element, and then delete the old. So this is not doing this dynamic stuff comes with a performance price. But in some cases, it makes your algorithms much easier to write. Like what I said, traveling salesman problem. It is so easy if you can gradually build up your route, and you don't care about it because the ease of programming completely outweighs it. Okay, so I did a test. I have a vector, I push elements onto it. I have a vector of a certain length, and I set the elements with @. I have a vector of a certain length, and I use the square bracket notation, and then finally I use the unadvisable new method. And I find that if you run this for, I don't know, 10,000, 100,000 elements, the pushback takes a certain amount of time. Using takes less time, and using square brackets takes even less time. Okay, so there is a factor of 8 or so, good 7, between the slowest and the fastest. But of course, other parts of your code also take time. So, okay, basically this means if you are at the inner computational parts of your code, do not use pushback. And you may even, I should also have timed how long it took to do the range-based. So so between the second and the third, there is overhead in bound checking, but yeah, keep the square bracket version to the innermost computational parts, and make very sure that you're not outside the bounds. Okay, so the vector class has certain overhead because it has to, the dynamic behavior definitely has overhead, but also the bound checking has overhead. And then, of course, the fact that the vector has to contain bookkeeping information on what is the size and maybe other things. So if you think this is all too much, then there is the array class. This only works for sizes that are known at compile time. So instead of include array, you do include, so instead of include vector, you do include array. Instead of standard vector, you use standard array. And now in addition to the type, it has the size. And so now the size is known at compile time. There is absolutely no overhead in anything in storage. And the other day I tested it out for myself. The compiler can optimize arrays just as far as C arrays. So basically never use old style C arrays, use vectors, and if you're really concerned about the little bit of overhead and your objects are static, then you can use a standard array. Okay. Oh yes. So this is C++20. Now, one thing you need to be aware of, I don't know how many of you, oh sorry, there was a question 5 minutes ago. Why does size equal 6? George, sorry, so you create the vector with size 5, and then you push an element onto the back. So really push as in add it to the end of the array, and so the size is 6. Okay, so a standard vector or a standard array owns its data. So unlike C arrays, where you could have one array and then point into the middle of it and pretend like that's a separate array, that doesn't work with C++ vectors. If you have two vectors, then they have completely separate data. If you try to take a subset of one vector and put it in another, then it will actually create new memory space and copy the data over. So one vector cannot be a sub-vector of another one in the real sense that it shares space. Now, I don't know how many people here do a lot of dense linear algebra with the BLAS library. So if you're into dense linear algebra, then you know that manipulation of the LDA parameter, the leading dimension parameter, allows you to do pretty good trickery with having one matrix and then setting a pointer to a submatrix. This does not work with C++ vectors. Fortunately, in C++20, there is a span, which is like a vector, but instead of owning its data, you give it a pointer. So you create a span of doubles by saying, okay, here is pointer to data, and this is what the size is, but the span does not actually own its data. So this is really cool for doing dense linear algebra in C++. Oh, by the way, I didn't mention the data method yet. So if you have a vector and you absolutely need to get to the actual address of the data, then you can do v.data, which gives you a double star. Literally a double star. So C objects, C thingamies. Okay. Ta-dum, bum, 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 bum. Vectors as function returns. Okay, so what am I doing? I have a function here, make vector, and you give it an int n, and then it returns a vector of integers of that length. And it initializes the 0 element. So this function creates a vector, and then it sets the 0 element to the size for whatever reason, and then it returns the vector. So this morning there was a question from Michael, who was asking, is the locally created object discarded? Yes. So yeah. Anyway, so you create a local vector here, and then it is either it overwrites x1 or x1 actually becomes that thing. It is the latter, but so there is no memory leak of anything going on. So make vector creates a vector, and then you can assign it to a vector object. Oh yes, auto is possible. So the compiler knows that make vector produces a vector of int. So it's redundant to say vector of int. So you can actually say auto x1 is make vector of 10. You can have code that contains very few explicit types. Usually the compiler can figure out what is happening. Okay, so a function can return a vector. Has anyone ever tried writing that in straight C, a function that produces a vector? It's a headache. Lots of double stars and stuff. Very confusing. You can pass a vector to a function. So artificial example, slope is the one element divided by the 0 element. Now, C++ is very systematic. If you do this, it's a pass by value, and pass by value was defined as copy the value from the main program into the subroutine, and in this case it means copy the vector, and I've just argued that copying a vector means creating a whole new memory area and copying everything over. So this is kind of, okay, you may want this, you may not. Just realize that C++ is consistent. It's always passed by value, meaning copying the value. Note that in C, if you would pass an int star into a function, then it copies the address, not the contents. I hope everyone appreciates this point. So this creates a vector that is a local variable inside the function. It's completely separate from what was in the main program. It's just that it has the identical content to what is in your main program. Okay, so some code that illustrates this. I make a vector v, I set v0 to 3.5, and then I call a function set0 where I give my function. Set0 is defined as take a vector and a value and set that value in location 0. Okay, but because this is passed by value, it creates a copy of the vector. And so you pass v, you pretend to set element 0, but if you print it out, you don't actually get 4.6, you get 3.5. Because passed by value passes a copy. If you would have passed your vector by reference, then, not sure where that output went to. It should have said 4.6. Right, so pass by value, pass by reference. And if you want to pass by reference because you want to save on copying, but you want to prevent yourself from accidentally changing it, then do a const reference. Okay, no need for pointers here. References are much better. Michael, if we use a ref to vector, then we are passing in and out of the function, address or copies. It just uses addresses. Nah, probably, but a reference, yeah, it deep down it uses addresses, but a reference is not an address. A reference is an alias. So it's a second name that acts like it is the exclusive owner of something in memory. But yes, if you declare vector float v, then it's passed by value, so the whole object gets copied into the subroutine. If you use a reference, then the v in the subroutine